Okay, so if we are to solve the equation 2 cosine of x over 2 minus the square root of 2 equals 0. So if we were trying to do that with a calculator instead of by hand, let me see if I can write this where we can read it a little better. Okay, equal to 0. And the answers here are supposed to be from, we want 0 to 2 pi for the answers. All right, so I'm going to start with typing in 2. Get this on mouse. All right, so 2 cosine of x, and I've got to close that cosine. Oh, actually, that was x divided by 2. Okay, close it. And then it is minus the square root of 2, so minus the square root of 2. All right, and then I'm going to go ahead and make this equal to 0. My equation was equal to 0 there. All right, at this point now, I want to make sure that my mode is in degrees, and it is. It's right there. It's in degrees. I'm also going to go, girls, I'm recording. Thank you. So I'm going to go to my window at this point. I'm going to make this 0 to 360 degrees and count by 30 degrees at a time. So it's going to be 0 to 360, count by 30 degrees. I'm going to go negative 4 to 4. Go to. Yes, Mr. Ashley? Do you need me? All right, negative 4 to 4. All right, and then I'm going to hit the word graph. So once I fix this window, 0 to 360, count by 30s, negative 4 to 4, I'm going to leave it like that for this entire test. And you guys can leave it that way for your final as well. All right, so again, I had gone to y equals, I typed in my equation, I put 0 for the second one. Okay, window, fix that just once, and make sure the mode was in degrees. Now I hit the word graph. Oh, something's not right. It's shading. Let me go back here and fix this so it's not shading. Oh, how do I fix it on here? Okay, maybe I have to write it out. There we go. Okay, that one's good. All right, go down the second one. All right, now let's hit graph. Okay, so I want to calculate this intersection right here. So I'm going to go to the word second, and above this word trace is that little word calculate right here above the word trace. So calculate. I'm going to choose number 5 for the intersection. And I'm going to move it close to that point of where they intersect. And I push enter for first curve, enter for second curve, enter for my guess, and that answer is at 90 degrees. Now they had wanted this answer in radians. So 90 degrees would equal to pi half radians. And that would be my answer. Okay. All right, let's clear the screen and do the next one. And go back to my y equals. Mouse. Y equals, and I also don't like that second one on yellow. Okay, now my next example, clear that line. Okay, so our equation is the cosine of 2x equals the sine of x. So cosine of 2x equals the sine of x. So when we go to type that one in, we are going to end up needing to type in the cosine of 2x, close it, minus the sine of x, close it, and I want to do equal to 0 again. Okay, so here we go. So cosine. Ben, do you want to come watch? So if there's a question you can ask in case I need to add it to the video.
Yeah.
and then I'm going to do minus the sine of x and close that. And again, it's equal to 0. My mode is in degrees. My window is already set. 0 to 360, count by 30s. -4 to 4, count by 1s. Okay, we will then look at the graph of this, and we're going to calculate these intersections to get the answers. Now, I could even make my window on those y's possibly be from -1 to 1, might be a little better. Oops, negative. All right, being that I want those intercepts, so it looks like it's just going to be tangent there. Okay, so again, that was in my window. I had just adjusted my y's a little bit further, like zoomed it in basically. Oh, the negative on here, I have to use this. My gosh, some of it I can use my keyboard and some of it I have to use the mouse. Okay, so I'm going to go to second, calculate above the word trace, number 5 for intersect. I'm going to move it. I'm going to just down arrow once and let it trace along the line y equals 0. If I up or down arrow, guys, see, it changes it to the first curve, and now it goes to the second curve on the red line or the blue line. So I just think it's easier to move it along the 0 line to that first intersection. Push enter for first curve, second curve, my guess. So that first answer is 30 degrees. So let me write that one down. All right, again, I'm going to go back to second, calculate, number 5 for intersection. I'm going to move it. But again, like I said, I like to move it on the 0 line instead. I'm going to get that next intersection, enter, second curve, enter, guess, enter. That answer is 150 degrees. Okay, again, we're going to go to second, calculate. And this time, I don't know if it's going to calculate it at that point of tangency. If I remember right, I think it doesn't sometimes. So looking at that, guess, enter. And so it's basically 270 degrees, 269.999 is 270. Okay, and then if it wants the answers in radians, then you put all those answers in the radians. So therefore, you would just convert each one by timesing by pi over 180, and then reduce each of those fractions. Okay, so that would be all answers in the interval from 0 to 360. Okay, or in the interval from 0 to 2 pi once you convert them. All righty, let me pause the video for a second. I think he needs something. Let me see, I gotta join this one. Pause. Okay, clear. All right, back to y equals and clear. All right, next example. So the equation is, you've got cosine squared of x minus, actually 2 of those, 2 sine squared of x plus 1 equals 0, and they want the answers from 0 to 360. So you wouldn't have to convert this time. All right. So how do we type that in with a cosine squared and a sine squared? That's where some students were asking me last period. All right. So first I'm going to do 2. We're going to do our cosine. I have to do the x, and I need to close it, then do the squared. So it's a little bit weird. So again, you're going to close your angle and then do the squared on the outside to represent cosine squared. All right. That then said minus 2 sine of x. Got to close it, then the squared, and then it was plus 1. And again, the equation was equal to 0. If it wasn't already equal to 0, I would make it equal to 0 by moving everything over. All right. Therefore, we already have our degrees. Remember, we'd already set the window 0 to 360s, counting by 30s. So we can go ahead and look at that graph now. I need these points of intersections. I was counting by 30, so I think the answer already is 30 there. I'm sorry, 30 plus 30, this would be 60. That would be 120. And then whatever these two would be. But if I'm not sure what those are, I then do my calculate intersection. So that's going to be second, calculate, number 5 for intersect. I'm going to move it to that first point. Now, see, I can finally see it, but if I up or down arrow, it puts it on the 0 line. That makes it easier. And I always just start with the very far left answer first. I find that easier. So first answer here is definitely 60 degrees. And we're going to go to second, calculate again. Number 5 for intersection. I'm going to down arrow once or up arrow once just to move it on the 0 line. Okay. And that answer is 120. and so forth. And you would get this answer and this answer as well. Okay, so that's how you type it in with the squareds. All right, and my last example, how do we type it in? We've got cotangents and cosecants. And with the cotangents and cosecants, you're always gonna have to be careful because sometimes, guys, it's the asymptote is a problem. And so it can lead to a little bit of issues there. All right, so let's go ahead and get our equation first that we're going to use. So my equation is going to be the cotangent of 2x minus the cosecant of 2x and equals 1. All right, so mouse, y equals clear. All right, so cotangent is going to be 1 divided by the tangent, the reciprocal identity of 2x. 1 divided by the tangent, 2x, close it. All right, then that said minus the cosecant. So that's going to be minus 1 divided by the reciprocal of cosecant is sine. So that would be the sine of 2x, close it. And then minus 1 to make that equal to 0. So minus 1, all right, and that's equal to 0. So again, when it says so this originally was, because it's kind of hard to read it. So this said the cotangent of 2x minus the cosecant of 2x equaled 1. So when I rewrote that, I wrote it as 1 over the tangent of 2x minus 1 over the sine of 2x, and then minus the 1 over. So that way I set this equation equal to 0. Go ahead and set that in that top basket. Thank you, sweetie. All right, let's clear that. Window's already set to 0 to 360. So I'm ready to go ahead and hit the word graph at this point. I need to calculate my intersections. It looks like I'm going to have 2 answers there. So then we're going to do our second. We're going to calculate number 5 for intersect. And again, if I'd left or right arrow, so I could finally see it. But remember, if I go ahead and just up or down once only, it'll put it on the 0 line. It's a little easier to move it there. First curve, second curve, my guess. And it said go to. So let's go to that mistake. And what's happening, this is where I was talking about that it's going to possibly give us some issues. So I'm looking at that and going, well, I counted by 30. So 1, 2, 3, 4 times. So if I went 4.5 times 30, that's probably where this is at right there. Okay. So 4.5 times 30. You got me there, sweetie.
35.
135. Okay. All right. And then we've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10.5 times 30, 315 degrees. All right. And then I need to make sure, so I could go to second table at this point then. So I go to second and I go to table and I could go ahead and put in 135 and I can put in the 315. The Y1's giving me an error there. So let me explain to you guys what's happening. Remember, we rewrote that as 1 over tangent. So if I was looking at the cotangent at 135, the cotangent at 135 should be -1. The sine at 135, those are times 2, sorry. So 2 times 135 is?
270.
270, okay. So here's what's happening. So when x equals 135, my original was the cotangent of 2 times that. So that would be at 270 minus the original of this one was the cosecant at 270 and minus 1 to equal 0. If I go to 270 down here, tangent is the y over x. The y over x down here is undefined. See, this is undefined, but not the original cotangent at 270. The cotangent at 270 would have been the x over y, which is a 0. The cosecant there would have been the reciprocal of the y, so that would have been a -1, then a -1 equals 0. So that's where I'm saying, so if we just understand that concept of that we were counting by 30s, how many of those did it look like? And then you could go to table and then you can check those. You could check the 135 and 315. Now, in case your table is not set up like that, you guys, what you would do is you do second, and the word right here above the word window is table set. And notice I have my independent on ask. So if you would put your table set on ask right here, just the independent variable. Okay, so I want this independent on ask, always leave the dependent on auto. So again, that was on second, table set. leave this one on ask. So when you have your X by table, you can tell it like that 4.5 times 30 there. Okay, and this 10.5 times 30. All right, that should be a big help there for lesson 7.6, both part 1 and part 2, y'all. All right, and let's stop recording.